Welcome to Adventures with a Very Small Lathe. My recent live streams from my desk have been difficult to set up as I don't have a good way to suspend a camera directly over my work area. I've been using these two cheap Noga copies chained together, but they aren't rigid enough and can't carry the weight of cameras better than this webcam. They also don't allow enough height range, which prevents me from getting the close-up shots I need. I figured I could improve things by making a rigid arm to give me a secure anchor position directly above the desk. I could then suspend a Noga arm from this point, giving me the freedom to securely position the camera wherever it needs to be for a particular shot. My first prototype was to create a single rigid shaft with a standard 1/4-20 tripod thread at each end. This would attach to the existing clamp and rest on top of the monitor for extra rigidity. I used 12mm aluminium rod to keep the weight down. To make sure the threads at the ends were hard wearing, I made the end pieces from steel. I had some bar ends of EN1A PB, leaded mild steel, that I've never used before, so I thought I'd give it a try. To attach the end piece to the shaft, I used a standard M10 thread for rigidity. The first step was to clean up the ends, drill them, and then tap the thread. I need a better M10 tap. This is from a cheap set and was really hard work to use, even on a soft material like aluminium. After cleaning up the face, I tapped exactly the same thread in the other end. The end pieces needed M10 threads to attach to the shaft and standard 1/4-20 camera tripod threads to attach to the clamp and Noga arm. The leaded mild steel was a real joy to machine, well worth using for simple projects like this where strength isn't critical. Sadly, it's hard to get hold of as the fumes are dangerous when it's welded or hot worked. First thread I turned was an M10. I used the same technique for all the external threads, feeding the single point tool away from the chuck with the spindle in reverse. Check out Joe Pazinski's video on this threading technique with the card at the top right. The technique is not only much safer, but can also cut more cleanly due to the higher RPM. First I cut a groove at the back of the thread with a parting tool. This is where the threading tool will start, and it also ensures the other part can screw tightly against the shoulder. I then used the thread tool to touch off the outer diameter and zero the dials on both the cross slide and the compound. Colouring the surface with a Sharpie ensures the first pass will be very visible to check it has the correct pitch. I moved the tool to the centre of the groove, engaged the screw feed, then ran the lathe in reverse as close as possible to the optimal cutting speed for the insert as I could get. As it feeds away from the chuck and the part, there's no need to worry about stopping it immediately after it finishes cutting. Pitch looks fine, so straight on to the next pass. I ran the lathe back at minimum speed and adjusted it the last few turns to the correct position by hand. It took about 12 passes total, including a couple of spring passes at the final depth. Once the thread was cut, I disengaged the screw, returned the dials to the 0 point, the original outer diameter, and ran a pass along the thread to remove the protruding burr. The other end of this part was a tripod thread, but the lathe screw gears were still set at the M10 pitch, so I delayed cutting the thread for now. In the meantime, I turned down the threaded portion, flipped the part to clean and chamfer the outer diameter, and then brought the end to the final dimension. The other steel end part required an identical M10 thread, which I didn't bother filming. This end is to be attached to a Noga arm or other fitting, so I drilled and tapped it as normal. Finally I switched the screw gear over to 1.25mm pitch, close enough to a 1/4 for such a short thread, and cut the tripod thread using the same technique as before. The end result is a rigid and fairly lightweight shaft which works fine for supporting any of my cameras above my desk. Alone it's rigid enough for most styles of camera, and resting on top of the monitor it can support my heaviest camera, as shown here. However, the fixed length makes it pretty inflexible, and with the angle I typically use I'd like to be able to extend it further from the monitor. For the next design iteration I decided to make a telescopic extension using suitable sized aluminium tube. As before, I made steel end pieces to ensure durability. The tube wall gave me less material to play with when attaching the end parts to the tube, so I flipped the threads around and used a custom thread based on the relative dimensions of a 0.5mm pitch standard metric thread. The basic major diameter I chose were 15.5mm, giving a bore diameter of 15mm. I machined the inside thread into the end pieces as the tube section was very long for my lathe and too large to fit into the spindle bore, making it very difficult to machine. First I machined the 1/4 tripod thread as the gears were still set up for this pitch. This end piece needed a blind internal threaded hole, and the other end needed a through-bored hole to the diameter of the shaft I made first. Both threads were equally tricky in practice, as it was impossible to see when the tool was at the correct starting point. I used this boring tool to cut a 2mm groove in the back of the hole for the thread tool to start in. Chamfer to ensure the thread start is clean. And zero the dials as normal. I used a dial indicator to locate the thread start position. To find the reference point, I touched the tool gently against the back of the hole, then moved away half the width of the groove. I then manually wound the chuck in the other direction to take up the backlash before taking the first pass. The thread is shallow at 0.5mm, so I only took a few passes. I wrote off one part by cutting it too deep, so I had to remake that one. This through-hole end piece was identical in setup, so I made it off camera. The final step was to drill and tap a hole for the locking screw. The tube section was too large for the 3-jaw chuck bore, so I switched up to the 4-jaw. This limited the speed I could run at due to its weight, but was worth it as I get way less chatter closer to the headstock. I took a slightly different approach to the thread to avoid using the parting tool this far from the chuck. Instead I used the thread tool to plunge cut its own starting groove and used the dial indicator to locate the groove so the tool could be returned exactly to the right place for the start of each pass. There was some chatter, but I got away with it. Cutting an internal thread this way would have been much more difficult. The ends of the tubes were essentially identical, so I machined the other end off camera. All the parts were now complete, so all that was left was to assemble them. As a bonus, the two different ends I had machined for the first prototype meant that I had more flexibility with how I attached the camera to the end. It's very satisfying to have chosen a custom thread and have it fit this well. The new prototype fits in place exactly as before, but as intended gives me much more flexibility. It's shown here extended to its maximum length. It easily supports the weight of my heaviest camera, but for stability at other heights I may have to add more support. With the male threaded end, it can be used to mount a camera directly. Thanks for watching, and I hope this was interesting. To see how it works out, watch my future live streams.